Hello, welcome to lesson 10.4, mutually exclusive events. So two events are disjoint or mutually exclusive when they have no outcomes in common. So this example here in this box says if you have shirts in your closet and some are blue, some are green, you randomly select one and it is blue or green. See how those are two separate things. The shirt is either blue or it is green, so they are mutually exclusive, okay? Now, two events are overlapping or not mutually exclusive when they have one or more outcomes in common, meaning they are like overlapping, okay? So basically, if you have shirts in your closet, some are blue and green, and then some are too big or fitting well, okay? Then if you are picking a shirt to wear and it is blue or it is too big, right? Can the one shirt fall into both categories? Yes, a shirt can be blue and it can also be too big, right? So if it's falling into two different categories, if it can be both, then we say it's not mutually exclusive. You know, those two things are not mutually exclusive. All right, so let's look at example number 1. So a cooler, and that's what we're doing first, is just determining whether they're mutually exclusive or not. So a cooler contains 14 bottles of sports drink, 4 lemon lime, 5 orange, and 5 fruit punch. You randomly grab a bottle. It is lemon lime or orange. Now, can the sports drink, there we go, can that be lemon lime, like both lemon lime and orange? No, those are two separate flavors. It's either lemon lime or it's orange, right? So if those two things are separate, then they are mutually, let's write this a little bit better. They are mutually exclusive, right? Because again, just to reiterate here, right? If they are totally separate, let's write that. Totally separate, that means it's mutually exclusive. If it can be both things, it can be both things, okay, both flavors or whatever, right, in the question, then they're not mutually exclusive if it can be both, if it's overlapping. Okay, so since these are totally separate, they're mutually exclusive. So number 2, there are 4 nickels and 7 dimes in your pocket. 2 of the nickels and 1 of the dimes are Canadian, the others are U.S. currency. You select a coin, it's a dime or it's U.S. currency. So can the coin, there we go, be a dime and U.S. currency? Can it be both of those things? Yes, right? It can be both of those things, so that would make it not mutually exclusive. Okay, so just one more time, if they're totally separate, they're mutually exclusive. If it can be both things, then it's not mutually exclusive. So go ahead and pause the video and try 3 and 4. All right, so number 3, it says a litter of kittens consists of 1 gray female, 3 gray males, 2 black females, and 1 black male. You randomly pick a kitten. The kitten is black or male. Can the kitten be both black and male? Yes, it can be both. So it is not, this scenario is not mutually exclusive. And then a box of chocolates contains 5 milk chocolates, 4 dark chocolates, and 5 white. You randomly select a chocolate. It is milk chocolate or dark chocolate. So can the chocolate be both of those things? Or are they completely separate, right? So the answer is no, they are completely separate. So if those two things are completely separate, we call it mutually exclusive. Okay, and the reason why we have to identify these things first is because we solve the problems in a different way. If they're mutually exclusive, if they're totally separate, right, it's a little bit easier to solve the probability. If they're not mutually exclusive, if there's some sort of overlapping, if it can be both, then we have to kind of figure out the probability in just a slightly different way. So let's look at that on the back page. And actually, let's just look at these. I know in the last lesson I said we could skip it, but let's stop and look at it. So when you have two, let's get back the purple. If we have two mutually exclusive events, we're going to simply add the probability. Pretty simple. So just to clarify, in the last lesson we multiplied because there was always more than one event, so we multiplied. In this case, it says you just randomly pick a coin. That's one event. So in terms of one event, we're not multiplying anything. We're just adding the different options because it's one event, right? You only multiply when there's more than one event, okay? And so in this first one, it says there's nickels, dimes. You randomly pick a nickel or a dime. So to find, since that is mutually exclusive, right, it could either be nickel or dime, not both. You're just going to add them, right? So your probability of getting nickels is 3 over 11 because there's 11 coins. Then plus the dimes, so 4 out of 11 because there's 4 dimes out of 11 total. So you get 7 over 11. Now, if you have two non-mutually exclusive events, meaning again, they overlap, right? We are gonna have to add the probability, but then we're gonna have to subtract the overlapping probability. And it's gonna help us to create a table. Now I'm gonna help you create the table in this notes here, this note section. And then in the assignment and the quiz and test, I've actually given you a table. So that part hopefully makes it easier. But you need that so you know how to basically add the probabilities and then subtract the overlapping one. And this says, so you have a cooler with sports drinks. Okay, some are different flavors, and then some are warm, right? Warm or cold. So if you randomly pick a bottle and it's orange flavored or warm, you're gonna have to add the orange flavor, the probability. So 5 out of 10 are orange, plus the warm would be 7 out of 10. And we're gonna subtract the overlapping, like what was both orange and warm. We're gonna subtract that, and then we'll get an answer that we're gonna simplify. Okay, so let's look at number 5. So this is a magazine contains 12 pages. You open to a random page. The page number is 1 or 7. So is this mutually exclusive? Yes, they're mutually exclusive because it's just, either 1 or 7. Those are two separate things, right? There's no overlapping. So what's the probability that you are, or let's actually write the words first. So since the page number is 1 or 7, so let's write page 1 over the total pages plus the fact that it's page 7 over the total number of pages, okay? I'm setting this up because, again, I'm just trying to figure out the probability that the page number is 1 or 7. So I'm just gonna add each of those things, okay? So how many pages have just page number 1, right? It is 1 out of a total of 12 pages, right? The probability of me opening up a page to page 1 is 1 out of 12. Now, it's the same thing for page 7. I'm just going to clarify this because of last year. I remember kids were confused. Page 7 means, if I open up the magazine, what's the probability that it will open up onto page 7? How many pages have page 7 or, it has 7 on it? Just one. There's only one page 7 in that magazine. So it's still 1 out of 12, okay? And then we just add those together. Now, the good thing about adding fractions is that, and our denominator is going to be the same because our total is going to always be the same in this lesson. So all we have to do is add the numerator, keep the denominator. So this would be 2 over 12. And remember, we're going to, in the assignment, put it as a decimal. So this actually simplifies to 1 over 6. But all you need to do is just put in 2 divided by 12. And we're going to do 0.167 because it's going to round to the nearest thousandths. Okay? 167, yeah. And so again, and the reason why we're doing this is because I just want to keep it the same. So we used decimals before, we're going to use decimals in this lesson. So just to be consistent. All right, so go ahead and pause the video. Try number 6 by yourself. All right, so this is a bag contains 4 red marbles, 4 blue marbles, and 5 yellow marbles. You randomly pick a marble. The marble is red or blue. So where am I getting the words from? Right here. Let's actually go back. I got the words from just the end of the question, right? So same thing back in number 6. The end of the question has what I'm looking for, right? Is it a red marble? So red out of total plus blue marble. Okay, so it's asking if I, put my hand into that bag of marbles, what is the probability that it is red or blue? So that's why I'm writing red plus blue, okay? Because it's mutually exclusive, right? They're two separate things. So I'm just adding the probability, okay? So how many marbles are red? It says contains 4 red, so I'm going to put 4 at the top. And how many total marbles are there? So 4 plus 4 is 8. 8 plus 5 is 13. So it is a total of 13 marbles. Okay, so blue. There are 4 blue marbles as well. So 4 goes in place of blue. And again, it's 13 total. So that goes on the bottom. And now when I add fractions, all I'm doing is adding the numerator, keeping the denominator the same. So 8 over 13. Let's change this into a decimal by taking the calculator, doing 8 divided by 13, and I get 0.615. All right, so now there's one more example. Now up here, it was mutually exclusive. For number 7, it is going to be not mutually exclusive, which means we're going to make a table to help us. So a bag contains 4 yellow jerseys numbered 1 to 4, and it also contains 4 purple jerseys 1 to 4. You randomly pick a jersey, it is purple or has a number less than 3. So our table is going to go like this because we have 2 different things going on, right? Because there's some overlapping, you have to think about where those 2 different things it could be, where it could be yellow or purple. So let's make yellow or purple. Doesn't matter if it's down the side or on the top. And then we have a number less than 3. So we have like the color, and then we have is the number less than, or is it greater than or equal to 3? So let's do less than 3. And then we'll put greater than or equal to 3, okay? So now let's think, now this is where it's a little, that's why I'm gonna help you with it. But I mean, it's really not too bad, right? Let's just think about it. If there's 4 yellow jerseys, right? How many of those yellow jerseys are less than 3? So that would be the ones 1 and 2, right? So there's 2 yellow jerseys that are numbered with a number less than 3. Now that means there are 2 that are 3 or higher, right? Right? Yellow jersey number 1, yellow jersey number 2, it goes in this first box. Yellow jersey number 3, yellow jersey number 4 goes in this box, right? And the same thing with purple. There's 2 purple jerseys with a number less than 3, and then 2 that are greater than 3, right? Like purple jersey 3 and 4 would be this box. You could draw pictures if that helps, right? I'm just trying to help you out with this table. So now that we have that, it says it is purple, so let's still write our word. So purple over total plus, and then number less than 3. So we'll just do a little symbol again. So less than 3 over total. And then we have to subtract what is overlapping. So that would be the purple and the less than 3 combined. Okay? And if you need to take some time, pause the video, make sure you write all this. Okay? That's purple over total plus less than 3 over total minus that overlapping part. So how many are purple? That would be 4, right? This whole thing is 4. And there's 8 total jerseys. And then less than 3 is this column. So see how there's 4 over a total of 8 that are less than 3. And then see how we counted something twice. That's why we have to subtract the overlapping, because we counted something twice. We counted this box here twice. So we need to subtract the purple jerseys that are less than 3. And there's 2 of those. Okay, so we have 4 over 8 plus 4 over 8, which is 8 over 8. Minus 2 over 8 is 6 over 8. And then let's make that into a decimal. 6 over 8 is 0.75, 3/4. And then let me just kind of point something out, a little shortcut. If you don't want to write all the words, which you should be, but you can also just kind of count. See how I circled here and I circled here? I could just count what I've circled. So 2, 4, 6. So I've circled 6 things, right? 6 out of a total of 8. So that's just one more way to think of it. Like I'm counting this 2, this 2, and this 2. That's 6. That gave me 6 over 8. Hopefully that makes sense. Otherwise, stick with this official way. All right, so last one. We're almost there. Please pause the video. Try number 8 on your own. All right, hopefully we tried it. I'm going to still help you with the box. This time it is apples and peaches. So let's do apples. Kind of divide here. Apple and peach. And then we have rotten. So we have like fresh and rotten. So it says 3 of the apples are rotten. Yes, 3 of the apples are rotten. 1 of the peaches are rotten. And there's a total of 6 apples. So that means 3 must be fresh. And if 1 peach is rotten and there's a total of 5 peaches, there must be 4 that are fresh. Okay. So now it is asking if it's fresh or it's a peach. So let's do fresh over total plus peach over total minus the overlapping of fresh peaches over total. So how many are fresh? That would be this column, which is 7. And how many total pieces of fruit? 6 plus 5 is 11. So there's 11. Then the peaches, there's 5 peaches. That total does not change in this lesson, so it's also going to be 5 over 11. And then the overlapping, what we've counted twice is this circle right here, this box, which is 4. So 7 plus 5 is 12. 12 minus 4 is 8. And let's make that into a decimal. So 8 over 11 is 0.727. Now, if I went too fast or you still don't understand, please let me know. I know this is another long video, but please come and seek me out if you need any help. Otherwise, I will see you in the next video. Bye.